Will Walt Disney make astronauts obsolete? A loaded question, no doubt. You join us as we will delve into exactly why the question is worth asking, what the implications of the answers either way might be, and of course give you a glimpse at some of the amazing, incredible things that robots and astronauts are going to be doing over the next few years. And no, as awesome as Mickey is as an attraction, it isn't the mice that are queued up to challenge human explorers. As you've come to this video, the chances are that you, like me, are partial to the idea that astronauts are pretty important. Initially then, it might be important to look at why robotics are already important in space, and then to look at how their future applications overlap with, and perhaps overcome, some major limiting factors about putting and keeping people in space. Colonel Chris Hadfield described the manipulator arm which adorns the International Space Station.
Canada built the Canadarm2, and Canadarm2 built this space station. Everybody should be proud of that.
A previous version of the arm was launched on the Space Shuttle, and the next generation has already been contracted out to Canada's MDA for the Lunar Gateway Station. You'll have to excuse the poor quality of the Canadarm footage from the early days. Cameras have progressed perhaps even faster than robots over the impressive 30-year history of Canada's main contributions to space exploration. It is perhaps interesting to note that Canada may reign supreme in space robotics today, but they also have a busy professional astronaut corps. Let's look at why they're invested in both today and how that might change into the future. This mini-documentary is brought to you by Giant-Leap.Space, the UK's space news, opinion and comment outlet. Classic thinking has humans as fast, adaptable, intuitive and inquisitive, whilst robots are slow, task-specific, detail-oriented and, at their worst, a dangerous liability. Indeed, robotics have been included in mass manufacturing for many years, but segregated from humans behind glass or cages. But with the advent of the 2020s, that opinion is fast being left behind. We're trusting robots to teach us about how to manage COVID, clean our homes and drive our cars, but that isn't all. Disney are taking things one step further, blurring the lines between human adaptability and the many benefits of robots here on Earth and in space. Not only are robots thought of in all of the perhaps negative ways described a moment ago, but they can also be robust, enduring, cheap, light, and if the worst happens, disposable. Astronauts are an expensive commodity in space, not least because these highly trained individuals are reasonably well paid, but because it's really hard to keep a human alive in space. The new space economy, to which the UK is a major contributor, is proving that getting technology to perform in space is a much easier and highly rewarding sector. As humanity moves forwards as a spacefaring civilization, astronauts are going to need to become much more generalised. We can't hold astronauts up as humanity's finest examples in the future, because there won't be enough near-perfect humans. Indeed, it's a wonder and a mystery that none have been caught up in any major publicity scandals to date already. Some explorers will always be required, and a highly trained astronaut corps is the right answer for that problem. But what about for the tasks of mining and using space resources in situ? Or closer to home, how about the task of inspecting space hardware, conducting repairs and routine maintenance? Spacewalks are a dangerous, grueling and expensive pursuit for human astronauts after all, and robots on Earth today are already performing some of these critical functions. This is a Boston Dynamics robotic dog inspecting the wreckage shortly after Starship serial number 10 exploded on landing, whilst the area was still far too dangerous for a human engineer to get up close and personal. And this is how satellites participating in on-orbit servicing are expected to start analysing objects and equipment in space as early as this year. By now, you're wondering how Disney come into this. Well, I'm glad to tell you it's in more ways than one. First off, Disney engineers known as Imagineers, I know, cute, published this video all the way back in 2018 of a robotic hand and arm capable of soft touch and gentle grip. This arm can and does use tools made for humans with as much dexterity, if not more, than the gloved fingers of astronauts in their thick protective spacesuits. Impressed? Well, so was I, and Disney were just getting started. This clip shows a fast, soft, human-safe handover between robot grasp and humans, an insanely difficult computing task just a few years ago. Remember Asimo? Disney aren't content to just demonstrate breathtaking technology, they're rolling it out as we speak. Here is a Disney-engineered robot performing acrobatic stunts autonomously. Yeah, this is real footage. This is not CGI, and if you think about it, why should it be? SpaceX's Falcon 9 first stage, or Starship, can autonomously land from space. Major caveat here, depending on when you're watching, Starship hasn't actually stuck an orbital landing yet, but the physics works and it's probably just a matter of time. Other emerging technologies seem to make robotics more enabled in space applications, which begs the question not if, but when astronauts will be replaced on spacewalks at the least. Would a merger between the Disney Acrobatic and the Boston Dynamics Inspection Dogbot make a percentage of spacewalks already conducted a dangerous extravagance for humans to attempt? And what if the task is towards the limits of a human? Managing object inertia in space is really hard and sometimes takes a huge amount of strength. It can lead to mistakes. These engineers have developed what they describe as a synthetic muscle with the strength to lift over 1,000 times its own mass. It's manufactured in about 10 minutes and, according to the New Scientists, costs about $1 to manufacture. That's an impressive capability. Human muscle is capable of much less. The equivalent here would be a newborn baby lifting a Land Rover. Okay, so in the near future, we will have robots such as this Disney Stuntronics robot absolutely killing their performances autonomously in theme parks, while surgeons can perform surgery more accurately, with less ongoing impact and better patient recovery times with the likes of this Da Vinci robot, all for cheaper than the value of a human astronaut, without a burden for food, water, or life support of any kind. Without the need for mental health monitoring, rest breaks or fatigue, and with significant superhuman strength to boot. But it's a lot of processing power to fit into one box, and that's one of the reasons human astronauts will be useful for some time to come. The truth also lies beyond the pure capability. There are moral questions that can probably only be answered by direct human exploration. And whilst the Western world sees the lives of astronauts as a precious commodity, dangerous industries today teach us that industrial processes will use people, even where machines could do the work, because it's cheaper, easier, and has a lower barrier to entry. It's also really worth remembering how astronauts spend their time. Unlike how many of us imagine it, pretty much constantly out of the door on a spacewalk, most of the time astronauts are using space as an environment in which they host their floating lab, known as the International Space Station. Astronauts spend most of their time conducting research in the lab, where computers have a different place in the pecking order, as a tool. But moving into the future, astronauts probably will have to move into monitoring industrial processes rather than carefully conducting experiments, and it is these commercial activities which generate such a lucrative opportunity for autonomous robots. One of the key things we've looked at today is the human operation of robots, the Canadarm, the Da Vinci surgery robot, and that little Boston Dynamics dog. But as missions move further from the Earth, autonomy becomes increasingly important. With a delay measurable in minutes to Mars or at least several seconds to the Moon, direct control of activity from Earth becomes increasingly difficult, or actually actively cumbersome. By matching the autonomy and situational awareness of an astronaut with the robustness and low requirements for life support for robots, we could seriously supercharge the way we operate from planet Earth. It has taken weeks for the Perseverance rover to move tentative meters on the surface. Indeed, for reasons known intimately only to NASA's JPL, the Ingenuity helicopter took days to drop both sets of legs into position and was delayed in testing its first flight. But if our robots were more capable decision makers, these could happen as quickly as humans would conduct these operations, and the speed that the science or the commercial product would come rolling in might well astound the scientific community and the general public alike. The great thing about astronauts as specialist generalists is that they can do just about everything with the proper support from the ground, with great task flexibility and pretty rapid by today's standards. Rather like fighter pilots, there's something special about having humans partaking in the activity that is perhaps essential to the pursuit at all. Just like fighter planes, it should come as no surprise to see that robots, even humanoid ones, will be deployed alongside their human counterparts to augment their effectiveness, keep them safe, and do most of the heavy lifting. With the natural human desire to explore and their ability to take legal responsibility for things, it seems unlikely that astronauts will become entirely obsolete, no matter how impressive our animatronics become. But it is certain that the right stuff are about to be joined inseparably by robotic counterparts with an equally valuable role to play in pushing the boundaries of human exploration, innovation, and even economic success. It's just a matter of getting the processes and the algorithms right to safely enable this technology to launch into generating value in space this decade. And speaking of algorithms, this platform relies heavily on your engagement to decide if our content is worth sharing. Seeing as you stay to the end, it would be amazing for me if you could like, subscribe, or even share this with even one potentially interested friend. This documentary is part of our limited series released early to our Patreon supporters over at patreon.com/Giant-Leap, where we also publish our weekly space news roundup early. Here's a link to our latest news on YouTube. Thanks for watching, and until next time, remember that every giant leap is made up of thousands of tiny steps.